All right, can everybody see my screen?
Yeah.
All right. So this will be the second class of second class, and just overview of today's class. We're just gonna, if anyone has any questions about the homework that I assigned, and they weren't able to message me or any of that, you can do so then. And then the main focus of today is gonna be the transformations. I'll go over what transformations are, the equations, and then give an explanation. That will probably take up the bulk of this class. And then we're gonna go over complex numbers and factoring quadratics. I think factoring quadratics will mostly be review for you guys. But then I'll just teach a few new things that relating to quadratic formulas. Does anyone have any homework questions? You can just put them in the chat, or you can just unmute and say it. If not, we'll just keep moving along with class. All right, I don't think I see any questions. Just remember to turn in your homework by the end of today. You can see it on Google Classroom. All right, so today the main focus is going to be about transformations. Transformations usually come in the form of so the first type of transformation we're going to be covering is going to be the absolute value function transformation. And this is the parent function. The parent function just means the function it was, every other function is built off of. This is the scaffolding. This is kind of like the equation for absolute value functions. But it does not have to contain all of these parts, the a, the b, the x, and the h, and the k. It can just contain some of these parts. So what do these all correspond to? So the h is responsible for horizontal translation, k is responsible for the vertical translation, a is for vertical stretch or shrink, and then if a is less than 1, it will shrink the function, and if a is greater than 1, it will stretch the function. And then for b, it is the horizontal stretch or shrink, and that is right here. And then if b is greater than 1, it will shrink the function, and if b is less than 1, it will stretch the function. And then if it is negative f of x, it will be a reflection across the x-axis. And then if it is the function of negative x, it will be a y-axis reflection. So these are just some very small discrepancies here. And now I'm just gonna skip ahead to kind of the explanation of this because it's a bit hard to draw. We're just going to be basing it off of this function right here, the y equals absolute value of x. Y can also be f of x. Those two are interchangeable in this case. So first, h and k are real numbers, meaning they're not imaginary numbers. So here are and then if just referencing the equation here again, the f of x or y is equal to a, the absolute value of px minus h plus k. So right here, you can see in this function, when we slide h up, notice, so it becomes, y equals absolute value of x minus h. And then you see when at h becomes positive, it slides to the right of the number line. As you can see, it shifts to the right hand side, as you can see. And then when h is negative, it shifts to the left hand side. As you can see, nothing else in the graph changes. The three dots right here do not change. It just shifts the entire function to the right or to the left. And then you can notice that when h is negative, it moves to the left, but then it shows up in the equation as positive. So let's just put h back to 0. And then K, which controls the vertical shift, you can see that when K is moving away from 0 positively, the whole graph moves upwards on the y-axis, as you can see here. The arrow, it might look like the graph is the function or the line equation is getting smaller, but it's just the appearance of it just getting moved up. And then when K turns into a negative, you can see that the whole line, the whole equation is moved down right here. So that is just something to keep in mind. And then as you can see here on the, I will put the week 2 slideshow in Google Classroom as well afterwards. So right here, when you can see how you can see the changes of y equals absolute value of x minus 2.5. And just to keep in mind that K is outside of the absolute value symbol, whereas H is the shift to left or right is inside the absolute values symbols. So those are just two things to keep in mind. So say if we had K of negative 2.5 and H of 3.5, it would look something like this. It would be shifted, the whole equation will be shifted down by 2.5 units, and then it would be moved to the right by 3.5 units. So that is what the K and H factors do in the absolute value function. And then next up, scrolling down here, we can see that there is a stretch or shrink right here. So when you see that the A function right here, that it is multiplying into this overall equation, as you can see right here. So this is the regular function of, we'll just set A to 1. So this is the regular function, the y equals the absolute value of x minus 1, minus 1. But then you can see when that A is plugged into there, you can see the focus, look at the 3 dots. You can see how the 3 dots go from their original resting position and they get stretched out vertically. Remember that A is in charge of vertical stretch or shrink. So as you can see, as A gets greater, the dots get stretched out more there. It is a vertical stretch. Because the dots are farther away from each other, they are stretched out. And then you can see that here, when A is less than 1, it shrinks. The vertical distance between the dots closes. As you can see now, the dot is at about negative 0.5, and this one is at positive 0.5. So the distance between that is about 1 unit. Whereas here, if it was just A equals 1, you can see that there is a distance of 2 units between the 2 dots. So that is just something to keep in mind here. The vertical stretch or shrink this is how it occurs. This is just the visual appearance of it. Of course, this vertical stretch or shrink doesn't just happen to these kind of V-shaped equations. They can also happen to parabolas, to lines, to other types of equations as well on the X and Y grid. So just keep that in mind. But this is basically what the vertical stretch or shrink is referring to. It's referring to how the points on the line get stretched out, on the equation gets stretched out or shrunken. Again, referencing back to the slide, if A is less than 1, it will shrink. And then if A is greater than 1, it will stretch. And then if we're talking about B, which is inside of it, the absolute value symbol, notice how it is just affecting the X. It is not affecting the negative 1. So this is purely affecting the X. And then you can see here how when B gets greater than 1, the dots are stretched, come together horizontally. right here, you can see the three dots, the length, the distance between each of them horizontally has shortened. Whereas if you extend it, the distance between the dots have lengthened horizontally. To kind of just give you guys a visual representation of that, you can see how between this dot and this dot, there is the distance of about 4 units right here. Whereas if we were to make it the equation 1, you can see that the distance, the horizontal distance between the dots shrunk. And then if we were to increase B even more, it would be the distance between them shrunk even further, as you can see right here. So does anyone have any questions about kind of how the transformation works, or any questions just in general about transformations? No? All right, we will continue then with some examples. All right, so here are just some examples for you guys to do. Just write the function of g of x whose graph represents a transformation of the graph f of x equals absolute value of x. G of x, it just means the function, the new function after translation. So just using the parent function of f of x is equal to a to the absolute value of bx minus h, absolute value plus k. So just will take about 10 minutes to kind of work through them. Of course, if you have any questions about how to solve these equations, let me know. I'll do the first one as an example. So first, as you can see, we have the horizontal stretch by 3. So that would mean that it would be g of x is equal to g of x is equal to absolute value symbol, a 1 over 3 x, and then minus 4 outside the absolute value symbol. So take about 10 minutes to work on that. And I just typed in the answer for number 1, so you guys can see it visually as well. All right. So someone asked how you would write the shift right 2 units. So just remember, H is regarding the horizontal translation of the graph. So if you were to write shift right 2 units, you at H would equal 2. So it would be g of x is equal, it would be x minus 2. It will take about another 5 minutes to work on these problems. And then after the 5 minutes are up, just put your answers in the messages box to me. It's fine if you don't finish all of the problems. I'll go over all of them one by one. Okay, I forgot to clarify this, but when you are doing an x-axis reflection or a y-axis reflection, so as you can see, negative f of x is an y-axis reflection. And what that means is that the whole that outside of the equation, it is multiplied by negative. So say an y-axis reflection, it would be the parent function, just using it as an example, it would be f of x is equal to negative whatever it is in the absolute value symbol, the k remains unchanged. And then if you were to do a y-axis reflection, since it would be f of the negative x, only the x would be affected. So for example, for the parent function, if you were to do a y-axis reflection, it would be f of x is equal to a to the absolute value of negative b of x. So it would directly affect the x value, whereas in the other occasion, it would be the negative would be attached onto the a, and it would just make everything in the absolute value negative. All right. If you haven't already, just put all of your answers into the chat box, and then we'll just go over. I'll just quickly run through the different all of the answers. So for number 2, it would be g of x is equal to absolute value negative x minus 2. That would be the answer. And then for number 3, g of x is equal to the absolute value of 1 over 5x, absolute value, plus 7. Number 4, g of x is equal to the absolute value of x plus 4 of negative x plus 4. The reason it would be positive 4 is because you are shifting up 4 units. So you would use k, the vertical translation, and k just represents how many units you're vertically moving the equation up. So if you were to move it up 4 units, it would be positive 4. And then for number 5, we would have g of x is equal to 8 times the absolute value of x plus 3. And then lastly, we would have, for number 6, we would have g of x is equal to 1 over 3 times the absolute value of x minus 7. All right. Does anyone have any questions regarding how I got those answers? All right. I see no questions, so I'll keep on moving forward. If any questions pop up later on, please feel free to just put it in the chat box. And, oh yeah, and also this is the link to where to the absolute value functions, the website that I was on earlier. This website. So if you want, it will be in the presentation that I send out after class. So if you guys just want to play around with transformations, kind of see how they work, how they visually appear, yeah, definitely check out this link. It'll give you a deeper understanding of how functions work and how they visually appear. All right, and now we're going to be moving on to complex numbers. So the complex number, we're going to dive deeper into this later on in the units. But first, just introducing you guys to I. I is equal to the square root of -1. Let me just add that in there. But I is equal to the square root of -1, which makes it imaginary because you can't have negative square root. So that's why it is a imaginary number. So I is equal to the square root of -1. These are just some useful things for you to remember, the powers of I. So I to the 0, like any other number, is just 1. I to the 1 is just I, or root -1. I squared is equal to -1. I cubed is equal to -I, and then I to the 4th is equal to 1. This is something that you guys should remember. I will keep popping up throughout your Algebra 1, throughout Algebra 2. It will be brought up later on in the unit and later on in your school year if you do take Algebra 2. So here are some examples. We'll take some time to work through them, and just heads up. So when you can't simplify I any further, you would just write it as simply as like 4I or something like that. You would not keep simplifying it. So for example, this one, the first problem, the answer would just be 6 minus 4I. You don't have to do anything with the I. you can just leave I, you can just write I as is. All right, we'll take about 10 or so minutes to work through these problems. If you have any questions, just send them to me in the text box and I'll answer them. Okay, we'll take about another 3 to 4 minutes to wrap up these equations, and then I'll just go over the answers. It's fine if you haven't finished them. If by the end of the 4 minutes you haven't finished them all, just put whatever you have solved into the text box. All right, I'll be going over all of the answers now. Please put your answers in text box if you have not already. Okay, so now hold on 1 second. All right, sorry about that. So for number 2, the answer would be 4 plus 2i. And then for for number 3, the answer would be 3 minus 9i. For number 4, it would be 13 plus 2i. Then for number 5, it would be negative 64. Next one, number 6, negative 48. Number 7, 41 plus 59i. Number 8, negative 252 plus 66i. And then number 9, negative 100 plus 56i. And then lastly, for number 10, the answer would be 57 minus 45i. All right. So does anyone have any questions about how I got those answers? Okay, I do not see any questions, so I'll keep moving along. All right, next up, we're going to be talking about factoring quadratic equations. I think most of this should be review. Just a quick few things. So again, the quadratic formula, x equals negative b plus or minus the root of b squared minus 4ac over 2a. And then you can only use the quadratic formula when you have the equation in the form of a x squared plus bx plus c equals 0. We'll just take 5 minutes to do these 4 equations. Again, as kind of a refresher to factor these equations, you got to find a number that multiplies two numbers that multiply to c, but then add up to the number in front of b. So for this one, since it's -3, the two numbers would be 3 and -1. Since they add up to +2. And then you would split the equation into p squared minus 1 plus 3 p squared minus 1p plus 3p minus 3, and then you would just factor that out. Okay, we'll take about another 2 more minutes and then I'll go over the answers. All right. I'll go over the answers now. If you have any questions about how I got these answers, just put them in the chat box. So for number 2, we have k plus 10 times k minus 3. K plus 3. And then for the next one, we have a plus 6 times a minus 6 times a plus 4. And then for the last one, we would have n plus 9 times n minus 1. For some of these, just make sure. So for number 2, why it wouldn't be k minus 10 times k minus 3, because if you multiplied that out, you would get k squared minus 13k plus 30. So just make sure that you make sure that the positive and negatives are correct. That's very important because sometimes you might have the right numbers, but then you might get the symbol wrong. You might accidentally put minus for plus or plus for minus. So I would just recommend double checking your work if you are not sure and just multiplying it out and making sure that it all equals out to the correct numbers. All right. Moving on. So this is so now I'm going to talk about finding the discriminant. The discriminant is just this thing. The discriminant is the b squared minus 4ac in the quadratic formula. That is what it is. It's just the discriminant. It's just a fancy way to say it. And these are just some things to know. So if the answer of b squared minus 4ac is greater than 0, then you have 2 real solutions. If b squared minus 4ac is equal to 0, then there's 1 real solution. And if b squared minus 4ac is less than 0, then there are no real solutions, meaning that the answer has either has like I in it or something that like that. It is the square root of a negative. So it just means that it is not a solvable solution. And this is just finding the discriminant is a really quick way to find the answers. If there's a problem on a test or homework saying, I'll find out how many solutions there are to this blank equation, the quadratic equation, you can really easily just say, oh, I have b, I have a, I have c, and then just do b squared minus 4ac. And then you can very easily determine how many real solutions there are. So this is just a shortcut for you, so you don't have to solve out the whole equation and then see how many real solutions or non-real solutions you end up with. So I think that is key, that it's just a shortcut for you that will help you. And then, so here are some examples. So just find the discriminant of each quadratic equation and then say the number of and the type of solution. So for the first one, I'll do that one. So for the first one, the discriminant would be -32, and then it would be two complex but not real solutions. What it means by complex solutions, it just means it has I in it, or it just has a negative square root. That's just what it means. And then the discriminant, you just get that by solving, just plugging in B, A, and C, and then solving. So we'll take about 8 minutes to just go through take 8 minutes to solve these problems. And then afterwards, I'll just go through the answers. Again, if you have any questions about how I got these answers, just feel free to put them in the text box, chat box. All right, we'll take about another 5 more minutes, and then I'll go over the answers. All right, I will go over the answers now. So for number 2, we have the answer for number 2 would be 121 and 2 real solutions. Number 3 would be negative 59, 2 non-real solutions or 2 complex solutions. Number 4 would be 0 with 1 real solution. Number 5 would be negative 75, 2 complex solutions or non-real solutions. Number 6, we would have 4 with 2 real solutions. Number 7, we would have negative 179 with 2 complex solutions or not real solutions. And then lastly, for number 8, we would have 0 and 1 real solution. All right, does anyone have any questions about how I got those answers? No, I do not see any questions, so we'll keep moving along. All right, and then next, and then I think this is the last thing for the day. This is known as completing the square. You use this when you have a quadratic equation where you can't solve it through regular factoring, where you will have to use this. So completing the square, there are 3 steps. First, rearrange the equation into ax squared plus bx equals c. So all parts with the variable with x or y or whatever onto one side of the equal sign, and then all other parts that have just numbers in them on the other side. Then you would add b over 2, b divided by 2 squared to both sides, and then you can factor and solve. So for example, for the first one right here, so we have k squared minus 8k minus 34 equals negative 4. So first of all, you would move the negative 34 onto the other side. That way and then you would get k squared minus 8k equals 30. And then through that, you can add b over 2 squared to both sides and then solve. And then the answer for that one would be 4 plus root 46 and 4 minus root 46. We'll just take, since it's the end of class, just do number 2, and then in 1 minute, I'll just quickly talk about number 2. I forgot to type this, but whenever you are answering for these equations, always make sure to use the fancy curly brackets. All right. Okay, I'll just quickly go over number 2 very quickly. So the answer to number 2 would be, with fancy curly brackets, 10 comma negative 4. That is the answer. So of course you would solve this by moving the negative 44 onto the other side. So you get x squared minus 6x plus 40. And then after that, you would add b over 2 divided by 2 squared to both sides. So negative 6 divided by 2, and then square root would be 9. So you would get x squared minus 6x plus 9 equals 49. And then you can solve it pretty easily. You have x minus 3 squared equals 49, and then you just square root it and solve. So I hope that wasn't too difficult. And with that, we have reached the end of class. Does anyone have any other questions?